Oh, hi, welcome back to the problem solving section. And we are still working on the surface integral. So we did one example. So if if you remember, from our last video, first we introduced what is the surface integrals, right? And so we say we have two ways to do it. First, if the parametric equation was given, then we did one example. So today we're going to do another two examples. It's showing if a parametrics were not given, but then you can define the function of a z equal to a function of xy, then we can use this formula, the negative p rho q rho x, rho g rho x, and the negative q rho g rho y plus r, and try to do the integration. All right, so now let's take a look here. Let's take a look at this example. Let's continue with here. All right, so for here, we said, okay. So for here, let's see here. So I have a vector field, negative x, negative z, and negative y, and the z cube here. All right, so as the surface is a part of this cone, all right, between the plane z equal to 1 and z equal to 3. So it's here z equal to 1 and z equal to 3. So here, that is the surface, right? So here, let's see here. So this is the surface we are trying to, oops, here. So here, let's see here. So this is the surface, right? So it's here from 0 to 1 to 3. And the one thing is here, we need to be very careful here. They said this surface is a downward orientation. That means this is a negative orientation. If it's negative orientation, what we need to do is, we need to put a negative sign, just like like in the calculus, you change the upper bound, the lower bound here. And all right, so in here, all right, so the first things here, we're going to apply that formulas, right? So let's see here, let's get all the values here we have. All right, so here the P, so the P is equal to negative x, right? And the Q is equal to negative y, and the R is equal to the z to the cube here. Okay, and then remember we said from here, if you go back to here, the formula we use here is the negative P rho G rho X, all right, and the negative Q. All right, so now I can rewrite this integration of this surface, this the green surface I circled here, the f of ds. So this one, okay, I can rewrite it. Remember we change it to everything is the x and the y's here. So be very careful because this is a downward, all right? So that means my integration going to be have a negative sign here. Okay, all right. So this is going to have a negative sign, and then all right. So here this will be this is z is equal to this one, right? So I can say this is my gxy functions here. Okay, so here remember the formula is negative p rho g rho x minus q rho g rho y and plus r's here, right? So here, look at here. So it's negative p plus r. Okay, so now let's do this. All right, so negative p. So this is negative p is negative x. Okay, times rho g rho x. So rho g, so the rho g rho x, that means gxy, you can put it as x squared plus y squared to the 1/2, right? So the partial derivative rho g rho x will just be 1/2. Then here will be x squared plus y squared to the negative 1/2. Then you change it, change 2x's here. All right. Okay, so now let's put it here. All right, so this is going to be times, all right, so this negative 1/2, I can put on the denominator. So this is x squared plus y squared. Then in here, this 2x and this 2, they cancel out, right? So this 2x, so this 2 and this 2 cancel out. So the top will just be what? The top will just be x, right? Okay, then plus, okay, so then what? Minus q, q is negative y, then rho g, rho y. Rho g, rho y is the same things here. So here is the partial rho g, rho y will be 1/2 x squared plus y squared, negative 1/2, and then chain rule dy, so I become 2y. So this ones here will be, so here will be x squared plus y squared. The 2 and the 2 cancel, here is y. Good? Okay, then plus z to the cube here. All right, z is square roots, right? So I have x square roots of the y square roots, what? The whole thing cube, right? And now I have I need to integrate the dx, dy. Okay, so let's simplify this a little bit. So for here, this one here is a positive, negative. So what is this one going to turns out to be? So this is going to turns out to be x squared. Then this is x squared plus y squared, right? Okay, so the same things here. Okay, so the same things here. This is negative negatives, right? So these terms are going to be positive y squared x squared plus y squares here. All right, so now my whole things here is going to be equal to negative. All right, so the negative and oh, what is that? Okay, so here it is going to be equal to negative. And then the inside here, right, so will be the x squared plus y squared. So this is x squared plus y squared. These two terms you can combine. This is x squared plus y squared plus x squared plus y squared square roots to the cube, the dA. So, right? All right, so integrating with some regions here. So this one's here. Okay, so here, then let's take a look, go all the way to here. So this will be equal to negative, right? So this x squared plus y squared cancel with the square roots. So will be the x squared plus y squared, then plus x squared plus y squared to the cube here, right? Then the dA is here. So here, okay, from here, if you want to find the x-y relation, still is not very easy to find. So what I need to do here, I see the x squared, y squared, right? So I change it to a polar coordinates, right? So I change it to the polar coordinates here. So what is the polar? We say x equal to r cosine theta, y equal to r sine theta. Hey, see here, so the x squared plus y squared become what? Become r squares, right? So then this whole thing is going to change, be very easy. So this is r squared. R squared, you take the square roots. So also don't forget the Jacobian for the polar is the r's, right? So the Jacobian for the polar is r's here. Okay, so now let's take a look. So these terms here, right? So let's be careful here. Let's color that. Okay, so this term is x squared plus y squared. This one is what? This one is r squared. You take the square roots, so it's r. And what happened to these terms here? So this term is r the what? R the cube, right? So this is r the cube. Okay, so this will be the r the cube. And now I have what? I have a Jacobians, right? So here you change it to the r plus r cube, then times r. All right, so remember that this is what? This is my Jacobians, right? So now you see, very easy. All right, so now I can say the dr d theta, because this is the areas, right? So dr d theta. So r is from 1 to where? 1 to 3. Then theta is from the 0 to what? It's 2 pi. So you can see this is negative 0 to the 2 pi, and then negative 1, 1 to 3. Then this will be the r squared plus r fourths dr d theta. So now it changed to a very, very easy integration. So you can just take the 2 pi, then you can move it here. This is 1, the d theta. Then this is 1/3, right? So r squared plus r fourths dr. So this one is very easy. So this integration will just be what? R the cube over 3 plus r the fifth over 5. Then you put in up bound and the lower bound, right? And then this one's here. Let's see which color one. Okay, then like this one's here will just become 2 pi. Of course, don't forget we have like negative sign. So after all, then the final answers here, it will be, okay, so if you want to, the whole number, it will, so this will be negative 1712 divided by 15 pi here, okay? Basically you just substitute the upper bound, the lower bound, and then kind of, you know, do the fractions, right? All right. Okay, so the next one's here. Let's take a look at this problem here. So this problem, oops, okay. Okay, let's, okay, so this problem is here. Let's do the similar things. So this one's here is y minus x plus 2z is the hemisphere x squared plus y squared plus z squared equal to 4. And z is greater than 0. And this is oriented downward. So I know it's oriented negatively. So I need to put a negative sign in front of it. All right, so let's do it one more time here, right? So the first thing is I want to create that g function. So I know the z squared is equal to 4 minus x squared minus y squared. So z is going to be equal to the square roots of 4 minus x squared minus y squared. So in here, because z is greater than 0, when I take the square roots, I don't need to worry about the positive and negatives, right? So this is my gxy functions here. Now let's take a look at rho g, rho x. How do I take the derivative? Rho g, rho x will be the same thing. It will be, so it's 4 minus x squared minus y squared. And this is give you a negative x. All right, so this will give you the negative x. And the rho g, rho y. So it's the same thing. So it's 1/2 and then 4 minus x squared. Then y squared, you chain rule. So it's a negative 2y cancel with 1/2. So it's a negative y. Right? So, okay, so now let's see here the integration for this surface. Okay, going to be equal to, all right, so remember the formula is negative p rho g rho x minus q rho g rho y plus r's, right? Okay, now let's see here. Negative p, so it's a negative y. Rho g rho x is this number, so it's negative x 4 minus x squared minus y. Then minus q. Okay, minus q is equal to the negative x. So minus q, that means plus positive x's, right? Okay, so here minus q. Okay, let's do this. Okay, q is negative x, so minus x's, right? So minus q is equal to the negative x's here. All right, and now, okay, and then plus times here times the rho g rho y. So times negative y, and here is 4 minus x squared minus y squared plus r. Okay, and then plus r is equal to, the r is my 2z's, right? So 2z, so is equal to 2, 4 minus x squared minus y squared. Correct? Now I'm integrating around the area, so we need to see what happens here. So this is dd. So this is negative, negative. So this is a positive xy. Then here is a 4 minus x squared minus y squared. This is a negative, positive, negative. So this will be minus xy 4 minus x squared minus y squared. Then plus 2, 4 minus x squared minus y squared dA. All right, so here, this one's here. So this is a positive, negative. I can cancel out. All right, so after I cancel out, now this one's here, I can change to, this is a D, so it's a 2, the 4 minus x squared minus y squared dA. So we know every time you see like x squared plus minus y squared, so what is the things we're supposed to do? Let's do a polar, right? Let's do a polar transformation, make the, so here, we do a polar transformation. All right, so the same thing. So I can set, so I would say x equal to r cosine theta and y equal to r sine theta. Jacobian is equal to r, right? Jacobian equal to r. So also I know 4 minus x squared minus y squared is r squared. So it's a 4 minus r squared cosine squared theta plus r squared sine squared theta. So it is equal to 4 minus r squared. Good. All right, so now this integration I can change to here, right? So it's 2 times square roots 4 minus r squared, right? 4 minus r squared times the Jacobian, right? So this is what we call this Jacobian. Don't forget that. So this is the Jacobian, and now I can change it to the dr d theta. So this is dr d theta here. So what is the r's here? So the radius is from 0 to what? 0 to 2, right? So this is 0 to 2. And then what is my theta here? My theta is negative, so it's from 0 to 2 pi. Okay, so one last thing. So here, be careful, because let's say it's oriented downward. So I'm going to have negative here. 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 All right, so don't forget, because this is oriented downward. That means I'm oriented negatively. Okay, so now for this ones here, this is going to be a pretty straightforward integrations, right? So for these ones here, you need to know maybe you can use like u sub, right? So u is equal to the 4 minus r square, then du equal to negative 2r dr here. So match perfectly. Then you can substitute back, and finally, all right, so finally you will be able to get this is what the we can move this negative 2 to the front, then 0 to pi, and then here you can say this is d theta, it's 1 times d theta, right? So then in here you can do the 0 to 4 minus r squared r's, right? So the dr, okay, so then you use u sub, for here, and then final answers here is going to be equal to negative 32 over 3 and the pi here. Okay, so after you finish the integration, you got negative 32 over pi. So those are the both methods here. I think, whatever which one you feel is more, the convenient, you feel more comfortable, you can use it for the service integrations. Remember? Okay, so the key things, let's try to refresh off memories, right? If the parametric equation is given, you can use this one, just your vector dot product, the RU cross RV. Or if not given, then but if you can place the z into a function of xy, then you can use these formulas here. So let's hear, like if you see like x squared, y squared, those things. So maybe you need to do a next steps here is to do a transformation, make your integration easier, like the polar, or maybe sometimes it's cylindrical, sometimes it's spherical transformations here. All right, that's it for the these two problems. So I think after we did both video, we should have a pretty good idea about how to do the service integration. So, right? All right, so let's talk to you next one. We're going to talk about the Stork series here. Okay, bye. Have a nice day. All right, bye-bye.